So what do you multiply by? It turns out that there's not one right choice. So I'm going to give you two options. Pick what works for you. Here's the first. If you are a person who likes to do just the same thing every time, so you know what you're supposed to do, this is the path to take. We're simply going to take the x's and eliminate them. They're the ones that are written here in the front, so they're the ones we're going to deal with. And here's what I would like you to do. The easiest and simplest way is to take a look at the numbers that are currently in front of the x's. What you're going to do is you're going to take the top equation by this bottom number, and you're going to take the bottom equation by this top number. That's going to give you your opposites. Now, you do need to be a little bit careful with signs. Here's what I mean. If we multiply the top equation by 9, then it's going to stay a negative as far as the x goes. That just means that down below, you would need to multiply by a negative to create a positive and get opposites. Let's take a look. On the top, let's multiply by 9. That's going to give us negative 45x's. 9 times 6 is plus 54y's. And then 2 times 9 is 18. Now, as you come down below, just make sure that when you're finished, you're going to have opposites on your x's. So if I multiply by positive 5, I'm going to have another negative 45x. That's not going to do me any favors. So let's multiply instead by negative 5. And there you go. Negative 5 times negative 9 is positive 45x. Negative 5 times the 6 is minus 30y's. Negative 6 times negative 5 is plus 30. And from there, you've got your set of opposites. Your x's will eliminate. For this next one, I want you to do the same thing. Let's go ahead, multiply to eliminate the x's. I'd like you to try it yourself, pause, and then unpause when you're ready to check. Okay, so our method is, take a look at the number in front of the x, which is a 1. That's what you're going to multiply down below. Take a look at the number in front of the x down here. It's a 4. That's what you're going to multiply by above. And then we need to keep track of our signs. If I multiply by positive 4 on the top, that's going to give me a negative 4x's plus 28y's equals negative 4. Awesome. If I multiply by positive 1 on the bottom, that's going to give me another negative 4. I don't want another negative 4. I want a positive 4. So just multiply by negative 1. Very simple. Look at that. So positive 4x's plus 4y's equals negative 28. Now when you add your equations, those x's are going to eliminate. Same deal. I'd like you to do a quick pause. Try this one on your own, and then unpause when you're ready to check your work. Okay, let's see what we got. I'm going to be multiplying on the top by a 7, and then on the bottom by a 10, and then let's check our signs. If I multiply the top one by 7, that gives me negative 70x plus 63y equals, and 29 times 7 is 203. On the bottom, 10 times 7 would be positive 70x, which is what I want. So we don't need to do any negative multiplying this time. 70x minus 60y equals negative 200. And then you would add up your equations, the x's eliminate, and you're good to go. If you like this way, do it. You can eliminate your x's every time. You are going to work out fine. Here's the second option. Some of us, I personally like to keep my numbers small, and sometimes that earlier method gives you numbers that are unavoidably big. So while the eliminating x method will always work, it doesn't always give you the smallest numbers. Let's take a look at what we got going on here. In this first example, if we do a quick examination of what we have, the 5 and the 9, okay, well, we see we can eliminate those. We did that up above. But take a look here. These are already almost opposites. As a matter of fact, if we just take one of the equations, how about the bottom one, and change the signs, we're going to have negative 5x plus 6y equals 2 on the top, and then positive 9x minus 6y equals positive 6 on the bottom. And look at that. Your y's eliminate and your numbers still stayed kind of small. So there's often a choice that's easy to spot that can keep your numbers overall a little bit smaller, which I like if I can help it. Let's take a look here at the next one. Here, do a quick pause. I want you to see if you can find the smallest number of multiplications with the smallest numbers you can do to get things to eliminate. Have you paused and tried it yourself? Here's where the most efficient solution lies. As I take a look here, this negative x and this negative 4x, it's going to be easy to get those to be opposites. 7 and 4, that's trickier. You'd have to multiply both equations to make it happen. But up here, if I multiply by negative 4, that's going to give me, on top, a positive 4x minus 28y's equals 4. And then on the bottom, a negative 4x minus 4y's equals 28. We didn't have to change the bottom one. We've got that set of opposites. Now, this is really similar to what we did on the previous page with the same problem. Okay, and then let's check this one. Now, here we are going to have to multiply both equations, unless you're really comfortable working with fractions. So here's what I recommend. Take a look at your numbers. 7 and 10, those don't have factors in common. They're kind of big. 6 and 9, those do have factors in common, which means it's going to be easier to find a least common multiple. Here's what I mean. I'm going to focus on eliminating the y's. Take a look at the coefficients of 6 and 9. Let's start with the bigger number and just start listing its multiples. So 9 times 1 is 9. Ask yourself, does 6 divide evenly into 9? No, you end up with a decimal. It's 1.5. Okay, now take 9 times 2. Does 6 divide evenly into 18? It does. It goes into 18 3 times. Here's what that means. I want to make my coefficients here be positive 18 and negative 18. That's going to keep my numbers as small as possible. Since the signs are already different, let's just multiply the top by a 2 and the bottom by a 3. Let's look at what happens. That's going to leave me with, on the top, negative 20x's plus 18y's equals, 29 times 2 is 58. On the bottom, 21x's minus 18y's, and look at that. There's my set of opposites, and it's the smallest set of opposites I could have, equals negative 60. Now your y's will eliminate when you add them up, and you can solve the system from there. So again, the trick we did, pick your variable to eliminate, start with the bigger number, list its multiples until you find one that also divides evenly by that other number. Multiply to make that set of opposites happen, in this case the 18s, and you've got the smallest multiplications you can do.